everyone, I'm Ibrahim Arif, and I worked on this project with Huma. In this presentation, we're going to explore the statistical trends in football player transfers from 2000 to 2019. We used data and statistical tools to analyze transfer fees, player ages, market values, and positional trends. Let's dive into what the numbers reveal. Understanding transfer fees. Let's start with transfer fees. One descriptive statistics. The average transfer fee is 945 million euros, while the median is 65 million euros, and the mode is 5 million euros. These differences show that most transfers are on the lower side, while a few high-value transfers push the average up to dispersion. The standard deviation of approximately 1,044 million euros indicates a wide range in transfer fees. There's significant variability, with small transfers making up the majority, but a few deals, like those above 100 million euros, skewing the data, skewness and kurtosis. Now let's look at the shape of the data. 1. Skewness. The skewness of transfer fees is 541, which is very high. This means most transfer fees are small, with a few very large fees pulling the distribution to the right. 2. Kurtosis. The kurtosis is 5972, indicating extreme outliers. These outliers, like transfers over 200 million euros, significantly affect the dataset. For player ages, the distribution is more balanced and resembles a normal curve. Most transfers happen within the prime competitive age range, around 24 to 26 years old. Probability of transfers by position. We also looked at the probability of transfers for different positions. 1. Center forwards. They have the highest transfer probability at 2,591%, reflecting their importance in modern football. 2. Center backs. Defensive players account for 1,519% of transfers, showing their critical role in team structure. 3. Central midfielders. Their transfer probability is 1,036%, highlighting their importance in controlling the game. These probabilities were calculated by dividing the number of transfers in each position by the total number of transfers in the dataset. Conditional probability, high-value transfers. High-value transfers are rare events. 1 probability, only 0.94% of transfers involve fees greater than 50 million euros. 2. Interpretation. These rare deals, such as Cristiano Ronaldo's and Pogba's transfers, highlight the exclusivity of mega transfers in the market. Conditional probability methods helped us understand this trend, focusing on the extreme end of the dataset. League-level comparisons, La Liga versus Serie A. To compare fees between La Liga and Serie A, we used hypothesis testing, 1 t-test. An independent t-test was conducted to compare the mean transfer fees. The t-statistic was 349, and the p-value was 0.00052. Conclusion: since the p-value is less than 0.05, we rejected the null hypothesis, confirming a significant difference in fees between the leagues. This result shows how leagues like La Liga tend to have higher fees, influenced by high-profile players and clubs. Correlation between market value and transfer fee. We then examined the relationship between market value and transfer fee. 1 correlation. A strong positive correlation of 0.83 was found. This means that players with higher market values tend to have higher transfer fees. Regression analysis. A regression model showed that 69% of the variation in transfer fees can be explained by market value. This highlights the importance of market value as a key predictor for transfer negotiations. Confidence interval for mean transfer fee. We also calculated a 95% confidence interval for the mean transfer fee. The interval ranges from 915 million euros to 975 million euros. This means we are 95% confident that the true average transfer fee lies within this range, providing a reliable estimate for clubs and analysts. Key takeaways and recommendations. The main points and recommendations. 1. Market value matters. Clubs should prioritize evaluating market value since it's strongly linked to transfer fees. 2. Focus on attacking players. Investing in center forwards is strategically beneficial due to their high transfer value. 3. League-specific strategies. Further research into league-level transfer trends can uncover unique market dynamics. Statistical analysis provides valuable insights into the dynamics of the football transfer market. By understanding transfer fee distributions, positional probabilities, and league-level differences, clubs can make more informed decisions regarding player acquisitions and strategic investments. Let's move towards our project Colab file. We coded this project in Python. Here's an overview of the process. Library imports. We started by importing the necessary libraries, data import, and cleaning. We imported our football player dataset and performed data cleaning. After removing irrelevant and inconsistent data, we obtained a clean version of the dataset. Descriptive statistics. We applied descriptive and inferential statistics to the dataset. Our results are as follows. Measures of central tendency and their graphical visualizations. Measures of dispersion and their graphical visualizations. Skewness and kurtosis, visualized by transfer fee and age. Histogram of the distribution of transfer fees. Box plot of transfer fees. Descriptive statistics for player age. Histogram of player age. Box plot of player age. Probability analysis. We calculated the probability of transfer based on player position. Conditional probability was visualized using a pie chart. Inferential statistics. We performed hypothesis testing, comparing the mean transfer fees in La Liga and Serie A. We found the correlation between market value and transfer fee, visualized through scatter plots and heat maps. Confidence intervals. We calculated confidence intervals to provide a measure of certainty around our estimates, visualized with graphs. That's all for this presentation. Thank you for your attention. If you have any question, please drop in comment section.